The screen fades from black to a dynamic juxtaposition of the deep blue ocean depths and the limitless expanse of the sky. Bold, electrifying text flashes across. Octopus versus Superman, a clash of superpowers. From the mysterious depths of the ocean to the boundless skies above, two worlds collide in a clash of unparalleled abilities. What connects the elusive octopus and the iconic Superman? Prepare to embark on an extraordinary journey where reality meets legend. We're juxtaposing the awe-inspiring capabilities of one of Earth's most intelligent invertebrates with those of the legendary Man of Steel. But this isn't just a fanciful comparison. It's an exploration of biology, physics, and the limits of possibility. Ever wondered how the camouflage of an octopus stacks up against Superman's X-ray vision? Let's find out. In this video, we'll delve into the deep technicalities of octopus biology and Superman's supposed physics-defying powers. We'll uncover surprising similarities, stark differences, and perhaps even learn something new about adaptation, resilience, and what it truly means to be powerful. Octopuses wield their camouflage like an artist wields a brush. Through a sophisticated system involving over 100 million chromatophores, pigment-containing and light-reflecting cells, they manipulate their appearance with astonishing precision. But it doesn't stop at color. They can alter the texture of their skin using papillae, muscular hydrostats that create bumps, spikes, and ridges. This shape-shifting ability, known as morphological change, allows them to impersonate other marine animals. From a biochemical perspective, their rapid color change is controlled by neuromuscular action rather than hormonal changes seen in other animals, enabling instantaneous responses to environmental cues. Octopuses possess one of the most complex nervous systems among invertebrates. With approximately 500 million neurons, they rival the neuron count of dogs. Remarkably, about 2/3 of these neurons reside in their arms, allowing for autonomous movement and sensory processing. Advanced problem-solving skills have been documented, such as navigation through complex mazes and solving intricate puzzles to access food. In lab settings, octopuses have demonstrated the ability to remember solutions and even exhibit observational learning, a sign of higher cognitive function. Their short lifespan, most live only 1 to 2 years, makes this level of intelligence even more extraordinary, suggesting a rapid development of cognitive abilities. When it comes to regeneration, octopuses are unparalleled among mollusks. If an arm is lost, a complex process of cellular dedifferentiation and proliferation begins. Stem-like cells at the wound site regenerate muscles, nerves, and even the sophisticated chromatophores. This regenerative capacity involves a well-orchestrated cascade of gene expression and signaling pathways. Octopus locomotion is a marvel of physics and biology. Their boneless bodies can compress to a fraction of their normal size, allowing them to infiltrate spaces as small as a few centimeters in diameter. This is due to their muscular hydrostat system, where muscles both generate movement and provide skeletal support. The coordination of their 8 arms involves complex neural computations. Each sucker can taste and touch independently, providing an immense amount of sensory data. Their movement patterns have inspired algorithms in robotics, particularly in the development of soft robots. Superman, or Kal-El, hails from the planet Krypton and possesses abilities that defy our current understanding of physics. His strength is often depicted as limitless, with feats such as lifting 200 quintillion tons, a number beyond terrestrial comprehension. His flight speed has been clocked at multiples of the speed of light in some comic iterations. His heat vision can emit energy beams hotter than the surface of the sun, while his superhearing can detect frequencies across vast distances. These powers provide fertile ground for theoretical discussions on energy manipulation, gravitational physics, and more. Superman's abilities are attributed to his Kryptonian physiology under Earth's yellow sun. His cells are described as solar batteries that store electromagnetic radiation and convert it to energy. This raises intriguing questions about energy absorption and storage at the cellular level. If we consider the energy output of the sun and the efficiency required for such storage, we'd be venturing into discussions of super-efficient photovoltaic processes and beyond. Beyond raw power, Superman's actions are guided by a steadfast moral code. often referred to as the Superman ethic in philosophical debates. His commitment to truth, justice, and the American way involves complex decisions that weigh individual rights against the greater good. In ethical philosophy, this aligns with deontological frameworks, where the morality of an action is judged based on adherence to rules or duties. Superman's choices often reflect a utilitarian approach. At first glance, an octopus and Superman might seem worlds apart, but both utilize forms of disguise for integration and protection. The octopus's camouflage is a physical transformation, adapting to its surroundings for predation or evasion. Superman's disguise is psychological, a cognitive adaptation allowing him to blend into human society as Clark Kent. The underlying principle is the strategic concealment of true identity to achieve specific objectives. The problem-solving prowess of an octopus mirrors Superman's strategic acumen, especially in scenarios where brute strength isn't viable. For instance, when confronting adversaries like Lex Luthor, Superman must outthink rather than overpower his opponent. This parallels the octopus's approach to challenges, utilizing intelligence and adaptability. While Superman's near invulnerability, stemming from his alien physiology, the octopus accepts vulnerability but compensates with regenerative abilities. This presents two different evolutionary strategies. In biomedical research, these strategies inform different approaches to health: preventative measures versus regenerative treatments. Let's construct a thought experiment, a computational simulation. Our setting: a technologically advanced coastal city. Both protagonists are drawn here by a convergence of peculiar events. This environment introduces variables that affect both parties: water bodies intersecting urban landscapes, advanced technologies susceptible to manipulation. The octopus, perhaps a genetically enhanced specimen, leverages its environment expertly. By tapping into the city's networked infrastructure, it manipulates data flows and control systems, disrupting communications and causing strategic blackouts. Utilizing chromatophores, it generates complex light patterns that could theoretically interfere with Superman's sensory perceptions. Superman approaches the scenario with caution. He employs his X-ray and telescopic vision to scan the environment, seeking to understand the underlying causes of the disruptions. Recognizing the octopus's intelligence, he attempts to establish communication. He might utilize his heat vision in a controlled manner to neutralize threats without causing harm. In analyzing this hypothetical confrontation, we apply principles from systems theory. The octopus represents a decentralized system, resilient and adaptable, while Superman embodies centralized power. Ultimately, the resolution might be a mutual recognition of intelligence and intent, leading to collaboration. From a neuroscientific perspective, the octopus challenges our understanding of cognition. Its distributed neural network suggests alternative models for artificial intelligence. Moreover, the octopus's ability to edit its RNA allows for rapid adaptation to environmental changes. This has profound implications for genetics and evolutionary biology. Superman's influence extends beyond entertainment into the realms of sociology, psychology, and cultural studies. He serves as a canvas for exploring the human condition, aspirations, and ethical dilemmas. In academic discourse, Superman has been analyzed in the context of Nietzsche's Übermensch concept. He represents an idealized form of what humanity could achieve. The octopus exemplifies biological adaptation through millions of years of evolution. Its evolutionary path demonstrates the power of natural selection. Conversely, Superman's adaptation is metaphorical, representing how an individual might assimilate into a new culture while retaining core identity. Our exploration reveals that intelligence and ethics are paramount. The octopus survives not through brute strength, but through cunning and adaptability. Superman often relies on wisdom and moral judgment. For experts in ethics or leadership studies, this highlights the significance of cognitive and moral faculties in influencing outcomes. We've journeyed through the intricate world of the octopus, unveiling its remarkable camouflage, intelligence, regenerative abilities, and flexibility. Simultaneously, we've dissected Superman's legendary powers, examining the theoretical underpinnings of his abilities. This fusion of marine biology and superhero mythology isn't just an entertaining thought experiment, it's a platform for cross-disciplinary learning. By comparing these two, we gain insights into the possibilities of evolution, the boundaries of physics, and the depth of ethical considerations. Perhaps, in understanding both, we inch closer to unlocking new frontiers in science and humanity. Now it's your turn. What do you think about this unconventional matchup? Are there other parallels or contrasts that intrigue you? Share your thoughts in the comments below. A heartfelt thank you to the marine biologists, neuroscientists, physicists, and cultural scholars whose work informed this video. Stay tuned for our next adventure, quantum entanglement versus teleportation, decoding the science behind sci-fi. Make sure to hit that notification bell so you won't miss out.